Okay, everybody, so I'm going to show you how to do an ANOVA. We reviewed this in class, but I was rushing through it because we were running out of time. Um, People had a lot of questions, which is fair. This is complicated. It's a lot to review. But let's break it down into its components, and you'll see it's not as difficult as you might think. And at the same time, don't be afraid to ask questions. If you have any questions, please reach out to us. Um, and okay, so let's start off by looking at your data. So all your data should be in this format. It should all look like numbers, unless you kept any variable just sort of to remind you of how you coded. But anything you're using for the analysis should be a number. So here you have the DV, and you'll notice it's a calculation of all the questions that were asked. If you're using a DV that's a yes or no DV, or in other words, a categorical DV, what I want you to do is, well, use a chi-square instead. You won't be using this tutorial. So another thing to keep in mind, for those of you using a scale, each of these questions is not a DV. You have to recalculate it and turn it into this one DV, right? I'm just averaging across and getting this value. I've made a video just for that, so make sure you look at that video. For those of you doing other types of DVs, like a math problem worksheet or anything like that, you include your DV. It should still be in one scale, right? I mean, in one row or column. So make sure it's in one column. Make sure you've labeled everything as you should. So, for example, here for sexual orientation, you see that variable, you go to variable view, and I'm going to double check that they coded it correctly. So this is an example from a group in class. You notice they have it coded. You could also go back to data view and click on this icon. And when you click on it, you should see all the labels, right? Here they labeled all the questions as, strongly agree, strongly disagree, and so on. That's fine. That'll help you remember what the values mean. You need to make sure you do that before you calculate the score. You need to make sure that if you only have the text, that you convert it into numbers before you do any steps beyond this point. Okay, so now I'm just going to show you how to do the ANOVA. So you go under Analyze, click on that, click on General Linear Model. Make sure you're not clicking on Generalized Linear Model. Then go to Univariate. Okay, so now I've clicked on that, and here you put your dependent variable. That I think is pretty clear to everybody. Some people were a little confused about where to put the IV. That goes under fixed factors. Okay, so you're going to put that under fixed factors, and they use sexual orientation and gender. And I'm going to go into options, click off descriptive statistics. So these are the means, these are the standard deviations. I'm going to click on estimates of effect size. So I forgot to include this. So for an ANOVA, the effect size you use is a partial eta square. I'm going to click on continue, and everything looks good. I'm going to press OK. Okay, good. So I'm going to walk you through this. Okay, the first thing you're going to notice is you have your total number of participants here. So here, just looking at one IV, sexual orientation, we see that in terms of participants, most of them were heterosexual. 13 identified as LGBTQ. And then, this is interesting. You have 2 and 3. So here I think what happened is this group had 2 other categories they didn't label. So make sure you've labeled all your categories, but let's ignore this for now. Then here they have female and male, right, for gender. They had 49 participants who were female, 30 who were male, and about 3 who didn't identify as either. I think they called it non-gender binary, something like that, or gender fluid. So then you look at the information here. Let's see. And Here you have the means and standard deviations in this next box. But I'm going to go to this last box and check to see if we had a significant interaction. Okay, so looking at this one, right, this row, where you have that star here, that means sexual orientation by gender. You know how sometimes you use a star for multiplication? So here they're saying using that for interaction. And you go here. You're looking under this column where it says sig. Make sure you're not accidentally looking at the partial at a square box. Column, right? This is the effect size. Here is where you get the p-value. So when you look at the interaction, you see it's not even close. It's not below 0.05. Here, when you go up a line, that's gender, you see that there is a significant main effect, right? Remember, if you have one IV, that means you're looking at main effects. Let's look at sexual orientation. It's not less than 0.05. We don't have a significant difference between, so for sexual orientation, we had heterosexual and LGBTQ, so you don't have a significant difference there. For gender, we had male, female, so we do have a significant difference there. So just as a reminder, when you do your analysis, you won't have this 3, you won't have this 2, if you labeled everything correctly. So to determine how it looks, right, to determine how gender, well, if there's a difference between the gender levels, right, if we have a main effect, we need to look at, well, is it male or female participants that are reporting more sexual harassment, right? Depending on your DV, it might be that did better on math, who are more confident in their digital literacy skills, right? But here we're looking at gender and experience with sexual harassment. So we're going to go here, and what you're going to see is here you have 2 levels of 1 IV. Okay, let me get rid of that. So here you have sexual orientation. So you have the 2 levels of sexual orientation here: heterosexual, LGBTQ. And you have here, well, here are the female participants who reported being heterosexual, and the average for their sexual harassment score. Here are the men, or the male participants who reported being sexual harassment, their sexual harassment score, and what they reported, right? Here's their average. And here is the total for all people who reported being heterosexual. Same thing here. Here's the female participants. Here's the female participants that reported being LGBTQ and their reported sexual harassment score. Here are the male participants who are LGBTQ and their reported sexual harassment participants. So I'm just going through that in case you do get an interaction and you're reporting these means, right? So if you get an interaction in the next paragraph after you report the interaction, in the next few lines, then you're reporting the means instead of main effects. Here we did not have an interaction, so we're reporting that main effect. And the main effect, again, was for gender. So here's sexual orientation. You might be asking, well, where is the gender variable? The gender variable, independent variable that excludes sexual orientation. In this case, because of how we set things up, it's here at the bottom. Just as another reminder, you won't get this, and you won't get this in your output. But then you look at these numbers to determine who is reporting the higher score. Well, looking at this mean, that only takes into account whether they reported being female, and it excludes looking at sexual orientation. We see that women are reporting a higher score, and that's a significant difference, or a significant main effect. It's not surprising, it's in line with the group's prediction, but that's your finding, right? So this is what you would report. So now let's say I had a variable, an independent variable that had more than one level. In most cases, most of you shouldn't have more than one level, but let's say you did. One group talked to me about possibly including a 3rd level, and that made sense. So if that made sense for your IV, and we talked it through, you would do this. For the rest of you, you're done, right? So you have the significant level you're looking at. You have the means you're looking at, and actually you're also reporting the partial eta squared, which is your effect size, right? So think back to when we talked about effect size. It's very similar to that. Um, the closer it is to 1, the well, actually, it's not that clear cut. Um, the higher the number, the better, right? So, for example, here we're looking at sexual orientation and gender, and the effect size for that, it's really low. That's actually bad. Here, this is actually good. It seems low, but if you look at the handout, you'll see that um, in terms of it being a small, medium, or large effect size, it's actually a very low number that you need to get to be considered a large, medium, or medium effect size. So you would report these numbers too. Okay, you look at the handout to see how you report those. Now I'm going to go into how to do the analysis if you have more than one level for one of your IVs. Okay, so I'm going to close this and say no to this. And I'm going to do the same steps: analyze, general linear model, univariate, and I'm going to use sexual orientation and ethnicity because I know that they have several levels for ethnicity. But now, because I know that ethnicity has more than one level, I do need to do post-hoc tests. So just as a reminder, if you get a significant difference for ethnicity or significant main effect, it doesn't tell you where the difference is. So you don't know if the difference is between Latinos and white participants, white and Asian participants. So you need these post hoc tests. I'm only going to do post hoc tests for any independent variable that has more than 2 levels. It's fine if you include all of them, so I'll just do that anyways. But the main one I need to make sure I have in here is ethnicity. I'm going to go with a Bonferroni post hoc test. I'm going to click on continue. All the options are set up the same way as before. They're saved. So once you do it one time, it's saved from the previous time. And I'm going to click on OK. Same information. Because I included gender again, you notice they have these 2 extra levels. Yours shouldn't have that. If you did have this, right, this 2 could have been non-gender binary. This 3 could have been something else. So make sure you clean your data so you don't have any numbers or any participants who are not accounted for. So in other words, you shouldn't have this in your output. Here you see for ethnicity, they have 6 different categories: American Indian, Asian, African American / Black, Caucasian, Hispanic / Latino, Native Hawaiian, Pacific Islander. So, okay, so here you have all the means and standard deviations for all the data. You have a lot of data here. Here you're going to notice some missing data because the numbers are just really low for some of their categories, right? So Native Hawaiian, Pacific Islander, these additional levels that weren't labeled are coming out blank because they only had 1 or 2 participants. But let's go here. Okay. So this is interesting. So when you look at gender and ethnicity, you do see a significant interaction. That's very interesting. So there is an interaction between gender and ethnicity on reports of sexual harassment. When we look at ethnicity and a main effect for ethnicity, we don't find a main effect for ethnicity, but we do find a main effect for gender again, right? That makes sense because we already looked at gender before. So you would report, in this case, this interaction and the main effect for gender. Now, you're not going to actually look at the levels. By levels, I mean the different ethnic groups and the comparison, because you didn't have a main effect for ethnicity, meaning according to this ANOVA, there's no difference between any of the ethnic groups based on this comparison. You might look at these numbers and say, well, it looks like a difference, right? Like looking at this group, African American and Asian, it looks like the Asian are experiencing more. It looks like the Caucasian are experiencing more. But take into account That's where the interaction comes in. Um, where you really see that is looking at so much at women of different ethnic groups. You see that when you take into account both, right? So comparing, for example, African American um, men to African American women. Well, you don't see it there, but you see it here more. Caucasian women to Caucasian men, you see a drastic difference there, right? So you're taking into account both ethnicity and gender, and you're seeing that both are influencing that DV, right? Um, but when you just look at ethnicity and ignoring, um, let's see, here you go. So ignoring, so here we have ethnicity and it means for ethnicity and standard deviations, ignoring gender. This analysis is telling us that there's no statistical difference here. In terms of means and standard deviations, it looks like a difference, right? Here you have it at 1.6. Here you have it 1.9. It looks a lot higher for Native Hawaiian, American Indian, but keep in mind when you look at the participants, we had like one or two in this group, right? So statistically, it's not going to show up, right? And that's why you have these missing standard deviations. So keep that in mind. In this case, you wouldn't really discuss the main effects. You would focus on the interaction and report these means, right? Right here. So for Asian female participants, this is what they reported. For Black / African American participants, this is what they reported. And I know this is going to take a while if you have this many levels, but you do that for all of these, okay? So that's it. If you have questions, let me know. Hopefully this is helpful.